All right. Before I get started, let's put our hands together for this wonderful TEDx team to put on this event today. You guys have been excellent. I appreciate you all staying for the very last talk. Also, I'd like to extend a special thanks to Ron, Jillian, and all the folks who were in the Career Services Department who are willing to host me for the Laurentians and residents. It's been a great program, as well as Bill and Lynn Fox. And Mom, Dad, Alex, Sam, and then whole Chan Farm, this one's for you. All right, so let's get started. Today, I want to talk to you about the origins and potential of artificial intelligence. But let's start with a quick definition. I define artificial intelligence as the ability for computers to learn, see, and think like humans. Now, if you take nothing else away from this next 10 or 15 minutes, know that you should all be thankful for three types of people, rather. Be thankful for teenagers and their raging hormones and their love for video games. Be thankful for nerds, like me. And also, be thankful for all those adrenaline junkies out there who got wads of cash and throw it like it doesn't stop. So, let's get down to the story. This isn't the first time that the world has been fascinated with the idea of artificial intelligence. It started in 1954 when some of the brightest minds in mathematics, computing, and physics gathered at Dartmouth University to discuss the potential for computers to think and behave like humans. These ideas ultimately proliferated academia and industry, promising breakthroughs in every sector of the economy. Billions were invested and eviscerated. Potential was hyped and deflated. Ultimately, all of this fell flat, which went to a time that we now call the AI winter. About a 30-year window of people who were generally skeptical and disillusioned by the potential of AI. So, what caused this false start? Why weren't we able to get AI off the ground the first time we tried? We were missing three key inputs required for any successful AI implementation: data, storage, and compute. Now, this is where an unexpected trio of people came to the scene: gamers, hipsters, and angels. And with this three unexpected trio, they ignited a fire of AI that is revolutionizing the way the world works today. So let's dig a little bit deeper. We'll start with these gamers. In the 1970s, it was the first time that entrepreneurs repurposed failed AI technology, and that took the form of video games and video game consoles. This birthed the multi-billion-dollar video game industry we know today. And as with the advent of the internet and additional technologies, and games became more complex, as graphics became crisper and the needs of gaming became faster, the computer chip industry had no choice but to keep up. And eventually, this birthed the graphical processing unit, also known as the GPU, a very key component of the rest of the story. Next, let's talk about those hipsters. Despite the depths of the AI winter, there were small factions of researchers and companies that kept the AI flame alive. Although a lot of their work was highly theoretical, it laid the foundation for how we teach computers to see, learn, and find complex patterns in any various types of data. Last, let's talk about those angels. In a world where 1 out of 10 startups makes it past 4 years, and where 1 out of every 1,200 startups sees a successful exit or IPO, angel investors are willing to seed early stage companies, give them money to launch their idea. Now, I call them adrenaline junkies because they put down big chunks of money with hopes to change the way the world works. So, how did this unexpected trio, gamers, hipsters, and angels, revitalize and awaken the energy behind AI today? Well, we solved all of our false start problems. In the 90s, angel investors made bets in internet search, media, video streaming. This gave us endless amounts of data, a data playground, if you will. Next, they also invested in fundamental technologies that allow us to store, access, and manage these endless reams of data that were coming from the newfound internet companies. Next, we pair all of that with a graphical processing unit offered to us by those gamers in the gaming industry. And this becomes a perfect storm for all of those research hipsters who now can take their highly theoretical work that had never been applied and use it. And today, AI is flourishing. Let's take a look at 2 examples where it's even saving human lives. This first example is diabetic retinopathy. Diabetic retinopathy is a condition where your eyes, nerves, and blood vessels suffer from damage as a result of complications from diabetes. We trained a certain component of AI known as computer vision to help doctors diagnose this condition using images of the eye. All the things you see outlined in white are areas where this algorithm has identified the potential of this type of condition. Now, training this algorithm only took 46,000 images, some where the condition was present, and some where it was not. After assessing the results and the diagnostic capability of this algorithm, we're able to find that it was able to achieve 95% accuracy. That's at or above the performance of human doctors. And now take into account that in addition to its diagnostic capabilities, it only took months to train this algorithm on the data. It takes a doctor 30 years of schooling and specialized training to perform this type of diagnosis. Let's take a look at another example. Autonomous cars. Once upon a time, we thought that driving was reserved strictly for humans due to the intricate nature of the action. Think about differing traffic laws from country to country, even state to state. Layer in then the complexities of other human drivers on the road. Well, for the first time in history, the self-driving car industry is publishing safety statistics on how well self-driving cars powered by AI are on the road. And it turns out, for every 1.92 million miles driven by a self-driving car, they only experience 1 accident. Compare that to human drivers, where we see, on average, 1 accident for every 492,000 miles we drive. This means that AI-powered cars are almost 4 times safer than their human counterparts. So, we've seen some examples where AI can revolutionize the way the world works and how it can save human lives, and how we have endless amounts of data and compute to power the most creative minds in artificial intelligence. It sounds like an absolutely glorious future, but is it? With every promise of a breakthrough technology, also comes the looming threat of widespread unemployment and job loss. In the past, you could hedge against this. Go to school, get a master's degree, PhD, a postdoc. You could also specialize by getting skills, learn a trade, get a certification. But this time, it's different. Algorithms and their computers can process thousands of images in hours, millions of rows of text in minutes, and hundreds of millions of lines of data in seconds. So, in a world where we would be outread, outprocessed, outmemorized, and outanalyzed by computers and their algorithms and their chips, how do we differentiate ourselves from our silicon counterparts? I think this lies in 3 uniquely human attributes: curiosity, communication, and empathy. Let's start with curiosity. Reinforcement learning is an algorithm that researchers use to train computers how to learn. The researcher sets a target outcome and gives the algorithm a set of parameters that it can pick from to achieve that outcome. Every time the algorithm is successful, that set of actions is rewarded. Every time that set of actions is not successful, it's penalized. So you can see how, if given enough iterations, this algorithm should be able to find the best set of actions to achieve an outcome. Now, one application of this reinforcement learning algorithm is training it to play a two-dimensional goal-oriented video game, where you're trying to take a game character from one end of the map to another. After subjecting this algorithm to 5,000 training runs, researchers were able to get about a 90% success rate, getting a character from one side to the other. And compare that to myself. As an avid gamer, I only have about a 50% success rate. So despite the fact that this algorithm is almost twice as efficient at surviving this video game level than I am, its one shortcoming is that it does not behave like a seasoned gamer. It doesn't look for power-ups, for shortcuts, or for Easter eggs. It doesn't explore actions outside of its programming. The takeaway here is that not every problem that we face as humans is an optimization problem. Innovation and invention are notoriously inefficient. And as we look to our role in the future in an AI economy, humans will definitely be required to define new problem spaces and new problems and partner with AI to find the optimal outcomes. Next, let's talk about communication. LSTM is short for long short-term memory. It's an algorithm used to make predictions on text. The most common application of LSTM is the autocorrect function on all of your smartphones. Now, let's imagine I'm texting my wife, and I say this to her. Do you really think she means to say, "what the duck" here? Probably not. Sam, I'm sorry I made that joke. What we struggle with here is human context in a computer-human communication. So let's take a look at another example. Let's imagine I were to take this LSTM algorithm and train it on the idea of radical, using text written by Marx or Stalin. When I try to take that trained algorithm over to the domain of physics or math and ask it to interpret the idea of radical, it's going to give me a completely different interpretation, very much like this string of text. So we know that in at least the short to medium term, the first need when it comes to human-computer interaction and when AI is involved is that we'll need a moderator to help fix shortcomings like this. But we will certainly need humans to be moderators as we move into more complex domains where context becomes increasingly important. Last, let's talk about empathy. As more corporations and governments embrace the use of AI, there is the potential for us to reach new efficiency frontiers, for us to see new markets and to create new products. But there is also the ability for us to exacerbate inequality and further bias. Let's take a look at an example of a theoretical hiring algorithm used by a company to identify the most promising managers and employees. If the existing management team is homogeneous, and we train it to identify more people like the existing management team, what do you expect will happen? When you hire and when you promote, you're only going to get more of the same. Now, it's tempting here to say, well, you know what, you built this algorithm and it's biased, and that's why your hiring practices continue to be biased. But that's not the case. The case is you trained an algorithm on biased data, and therefore you get biased results. Remember from these previous 2 points, these algorithms are not context-aware, and they do not explore things outside of their programming. We need the people who create, deploy, and manage these algorithms to speak up and to identify these types of biases so they can be fixed in the algorithms themselves. Now, this is where empathy becomes critically important. When you're applying for credit cards, getting mortgages, applying for school, going to grad school, or you're moving to a new state, AI algorithms may be powering policy and decision-making in the background, and you don't even know it's present. In some cases, it may benefit you. In other cases, it may hurt you. There will be people in this economy and in this world who are interacting with AI who will be on the losing end of those decisions. And you cannot be afraid to speak up for those who do not have a voice. So, in summary, in a world where AI looks like it's chomping at the bit to automate all of our jobs and take away everything that makes us human, how do we remain relevant in the AI economy's workforce? I believe you have to be curious. As we've learned, Not every problem is an optimization problem. We still need humans to invent and innovate and create new problem spaces. Second, you must master the art of context. Computers are advancing when it comes to communication with people, but we still lack the ability to derive deep context in those communications. And last, but certainly not least, show empathy, be brave, and lead. You must hold those who use AI, deploy it, and make decisions off of it accountable for their actions. Because after all, we don't know what those gamers, hipsters, and angels have in store for us next. Thank you.